a multiple choice question from binomial theorem. This one is from NEST 2010 and it is question number 14 from the official PDF. The coefficient of x raised to 100 in 1 plus x raised to 100 into 1 minus x raised to 101 upon 1 minus x is 1, 200, 100c2, 2 raised to 100. Now what we are going to do is we are going to split the given expression into two terms. First term is 1 plus x raised to 100. We can solve it or expand it using binomial theorem. And then we have got this 1 minus x raised to 101 upon 1 minus x. We shall see how to simplify that. Okay? Now, what is the expansion of 1 plus x raised to 100 using binomial theorem? It will be 100c0, which is 1, into x raised to 0 plus 100c1 into x raised to 1 plus 100c2 into x raised to 2, and if we continue writing this, then we will reach 100c99 x raised to 99, and then the last term 100c100 x raised to 100. Okay? Now when it comes to 1 minus x raised to 101 upon 1 minus x, let us remind ourselves that we have already seen something similar when it comes to a geometric progression. Okay, suppose we consider a geometric progression whose first term is 1 and whose common ratio is x. What is the formula for the first n terms, if you remember? The formula is 1 minus x raised to n upon 1 minus x. And if you compare this expression here with this, then you will realize that it is actually the sum of first 101 terms, isn't it, with n equal to 101. So what is this GP? 1 plus x squared plus x cube, and mind you, we are not going till x raised to n. Okay, we are not going till x raised to n. We will stop at x raised to n minus 1. Why? Because first term is n, first term is 1. So if this term is 1, so x raised to 1 is the second term, x raised to 2 is the third term, x raised to 3 is the fourth term, so x raised to n minus 1 will be nth term. Got it? So to stop at n minus 1 and don't write raised to n as the last term. Okay, fine. So using it, we can now happily write this as 1 plus x squared plus x cubed. Now how far are we supposed to go? N is 101, so we should go with until x raised to 100. Correct? We should go with x raised to 100. Now let us come to the problem. They are saying the coefficient of x raised to 100. Now x raised to 100 can be obtained when we multiply the terms of 1 plus x raised to 100 by the terms of 1 minus x raised to 101 upon 1 minus x. Got it? We'll start with this. Okay, we'll start with 1. This one will be accompanied by this 100c100 into x raised to 100. This x will be accompanied by 100c99 x raised to 99. Then there will be x squared. I have not written this here, but it will be 100c98 x raised to 98, so on and so forth. Okay. Now when we come to x raised to 100 here, it will be accompanied by 100c0 into x raised to 0. When we go to x raised to 99, it will be accompanied by 100c1 into x raised to 1 and so on. So for x raised to 98, we will have 100c3, 100c, oh sorry, for x raised to 98, we have 100c2 into x squared. We haven't written it. And for x raised to 97, it will be 100c3 x raised to 3. Got it? Therefore, coefficient of x raised to 100 is, now pay attention, let us start with the first blue tick. Let us start with the first blue tick, so that will be 100c100 plus. Now the two blue ticks, x, and there it is 100c99 x raised to 99, so 100c99. Then the third blue tick, x squared, it's not there, but we know what it is now, 100c98 Okay, and 100C 97, 100C 96, 100C 95, all of those terms will be there. Now let us start with the two blue ticks, x raised to 1 into x raised to 99 accompanied by 100C1. Then single red tick, x raised to 100, x raised to 0, so x raised to 100 into 100C 0. Okay, so what do you see? You basically get the sum of the binomial coefficients. And we know what is the sum of the binomial coefficients. That is always 2 raised to n. And what is n here? N is not 101. N is 100. So it's 2 raised to 100. So what is the answer? The answer is 2. Okay. So in this sum, we have used three things. First, what we have used is we have used the formula for binomial expansion. Second, what we have used is we have used the sum to n terms Sn of a GP. And third, we have used the fact that sum of the binomial coefficients is 2 raised to n. Okay, I will encourage you to prove this result. It's very simple. What you have to do is you have to take this and then put a and b both as 1. You will get the result that we have used. Okay, so answer to question number 14 is D.